Hi friends, welcome to the Unit 2 Day 7 notes. This one we're going to be talking about the example of writing piecewise defined functions given a graph. I went ahead and gave you what the linear component and the quadratic component of this graph is. Sometimes you're given, sometimes you're not, and you have to figure it out, given with the information. This one I gave it to you because it's hard to tell with the quadratic, but you could find it knowing that this is the vertex and this is the point on the graph. The linear component of this graph is f of x equals negative x plus 3, and the quadratic component of this graph is f of x equals negative 2x squared plus 8x minus 4. So to find the function that defines this graph piecewise function, we actually need to define what happens here. And if you think about what's happening here, I can't have both of these points existing at the same time. So I'm going to say that this point actually corresponds to the linear component, and then it's kind of an open dot for the quadratic. Now, it's hard to tell from the graph, which is why it's important that we define it within the piecewise. So as we read it from left to right, also we're going to assume that these continue on forever in both directions. So it said the function, so we'll call this let's call this g of x. G of x equals, and then here we have negative x plus 3 when, so this comma here shows when, and this will be x is less than or equal to 1. Now I'm saying x is less than or equal to 1. This is the domain. Remember we said it was equal to for the linear component. And then negative 2x squared plus 8x minus 4 when x is greater than 1. You will never have a time where you have both equal to's here because it can't be a function and then exist 2 points simultaneously. And for this one, it doesn't matter which one we picked because they'd happen to correspond to the same part of the graph. Piecewise defined functions can be graphed by plotting points and paying close attention to the domain. A more efficient way is to keep the transformations of the parent functions in mind while noting the endpoints of the domains. And we have to be really careful about when we exclude or include or exclude values here. So let's talk about graphing. Join me in the next video as we go through and graph.